Hello and welcome back to e-sipnayan. For today's video, we are going to discuss how to solve word problems involving the normal distribution. But before we proceed, do not forget to hit like and subscribe so that you'll get notified once we upload new videos. This video will be having this learning objective, which is for you to be able to solve word problems involving the normal distribution. So to start off, let us recall how to solve for the area above, below, and between, because these are the cases that we are going to use in the word problems later on. Now, this will be a little bit modified because we are talking about real-life cases or word problems. So this will now be the steps in solving for the area or probability involving word problems. Emphasis on word problems. So we usually start by solving for z. But before anything else in solving word problems, we need to start by adding or subtracting something to the score depending on the rounding of given. That will be further elaborated later on, but for now, let's recall how to solve for the area below, above, and between. Now, all of these cases will be solved by solving first for z. So the default is getting the area below by solving for z, then use the z table to identify the area or probability. For area above, same steps, but we need to subtract the obtained area from 1. And for area between, same steps, but we will be solving for 2 z's. We will be locating for 2 areas, and we are going to get the absolute value of the difference of the areas identified. Or we can subtract the higher area to the lower area. We start with example number 1a. The weights of a large number of miniature poodles are approximately normally distributed with a mean of 9 kilograms and a standard deviation of 0.8 kilogram. If the measurements are recorded to the nearest tenth of a kilogram, find the fraction of these poodles with weights over 7.5 kilograms. Now, this is a problem involving the normal distribution because notice that it is stated here that the weights which we are measuring is approximately normally distributed. Now, this is our clue. We are tasked to solve for the fraction of these poodles with weights over 7.5 kilograms. So this fraction is just a ratio and we are talking about the probability or area here. We start by identifying what we are solving for, and that is the area of weights over 7.5 kilograms. This is the fractions, also the area of the weights over 7.5 kilograms. Now let's try to identify if these keywords will represent area above, below, or between. So when we say over 7.5 kilograms, say for example 7.5 is somewhere here, if we want to know the probability over 7.5, we define literally over, and that is going beyond 7.5. So if we want values greater than 7.5, then 7.5 should not be included. So this is a value not included because we only want values over 7.5, and that is area above. So if you see the word over, that means area above. Now notice here that the weight is recorded to the nearest tenth. This will be our clue for the first step before solving. Now since we know that over 7.5 means area above 7.5, and that means not including 7.5, we need to adjust our value for x. And how do we do that? We simply try to increase it a little over 7.5. So since we know that over 7.5 means area above 7.5, and we were able to know that 7.5 is a value not included when we define over 7.5, then we need to adjust the x value a little over 7.5. Now, what will be our basis? That will be the rounding off given. And here it is stated in the problem that we need to round it off to the nearest tenths. So if we want to round it off to the nearest tenths, which is in this case here, representing 5, we need a number to its right to be able to round it off. So we need to add a value to 7.5, which will help us to round it off. And the safest is 0.05. To begin solving, we need to round off to the nearest tenths. Now, why 0.05? It's because we want a value a little over 7.5, and we should be rounding off to the nearest tenths. Now, it's always values of numbers like 0.5, 0.05, 0.005, and so on, depending on where you are rounding off. So the new value of x here will become 7.55. 7.55 now is a safe value wherein 7.5 will not be included. Because if we consider 7.55, that will be to the right of 7.55. Hence, if we consider this area or probability, 7.5 will not be included. And that's what we want because we are pertaining to areas over 7.5 or values rather greater than 7.5. We need to identify if we are going to add or subtract the score. Since we want or since we do not want to include 7.5, we need to add something to it so that it will not be included. So that will be now 7.55, and that is the new value of x. Now we'll proceed to the usual. Solve for z given the new value of x, which is 7.55. We will now forget 7.5 and we are going to plug in 7.55 instead. So substituting to the formula x minus mean all over standard deviation. X is 7.55, mean is 9, standard deviation is 0.8. Solve it and you'll get approximately negative 1.81. So next step is to identify the area below. So that will be negative 1.81. We're going to use the z table. Negative 1.81, this is negative 1.8, this is 1. So their intersection is 0.0351. So going back, the area below is 0.0351. And since we want the area over, which means area above, we need to proceed to step 3, wherein we need to solve for area above. And that will be 1 minus the area below, which is equal to 0.9649 or 96.49%. So to be able to answer this problem, the fraction or the probability that the poodles will weigh over 7.5 kilograms is 96.49%. For example 1b, same scenario, but we are now solving for the area that these poodles will weigh at most 8.6 kilograms. So when we say at most 8.6 kilograms, that will be less than or equal to 8.6, which will be related in solving for the area below. So at most 8.6 represents area below. If we have here an illustration of 8.6 and we want values at most 8.6, that will be pertaining to the value starting from 8.6 then to its left, which explicitly shows that we are pertaining to area below. Now the next question here is 8.6 included or not? Again, we need to define literally the keyword. So the keyword here is at most. When we say at most, should 8.6 be included or not? In terms of symbols, that's less than or equal. So this equal symbol means we will be including 8.6. So if we want to know the area below, including 8.6, we need to add something to the value of x so that it will be included when we consider the areas to the left. So we are going again to add 0.05 since we are rounding off to the nearest tens. So if we add 0.05, we'll have here 8.65. And if we consider 8.65 and everything to its left, definitely 8.6 will be included. And that is what we want when we say at most. So round off to the nearest tens and add subtract to the score. We are initially given with 8.6. We are adding 0.05. And we will now have a new x value of 8.65. So the usual steps in solving for the area below, solve for z. That will be 8.65 minus 9 all over 0.8. So again, the x value that we are going to use is 8.65 and not anymore 8.6. So simplifying, we'll get negative 0.44. So again, we use the z table, locate negative 0.44. This is negative 0.4. This is 4 and we'll get 0.3300. Therefore, the area below is 33%. For example number 2, the intelligence quotient or IQ scores for people are normally distributed with a mean of 100 and a standard deviation of 16. If Bettina was randomly selected to take the test, what is the probability that her score is between 100 and 120? We are solving here for the area between 100 and 120. So we need again to identify whether or not the values will be included. We are solving here for area between, that's why we have two scores. This is x sub 1 and this is x sub 2. If I try to plot it on a number line, let's say 100 is somewhere here and 120 is somewhere here. And if we literally define between, that means we are simply pertaining to the values between the given range. So that means we do not want to include 100 and 120. They are not included. We only want the values in between. So in this case, if we do not want to include 100 within this portion, then we need to add. So that will move to its right. Meanwhile, for 120 to not be included, we need to subtract so that we can move to its left. And therefore, if we added, we move to the right. If we subtracted, we'll move to the left. We'll be considering this portion only. So here, in this case, there's no particular rounding off that we need to apply. That's why we will already assume that we are rounding off to the nearest whole number. So if we have a whole number, we need a number to the right for us to be able to round it off. So that will be adding 0.5 and subtracting 0.5. So the new value of x sub 1 will be 100 plus 0.5. The new value of x sub 2 would be 120 minus 0.5. So our keyword is between 100 and 120. Round off to the nearest whole number. I already added it a while ago. So why nearest whole number? Because there's no specification as to where are we going to round off. So in default, we are rounding off to the nearest whole number. So step 0 is to add and subtract the scores. The new value of x sub 1 is 100.5, while x sub 2 will now be 119.5. So since this is area in between, we are going to solve for two z's and identify two areas. Let me just correct this. So for z sub 1, that will be x sub 1, 100.5 minus mean, 100, all over standard deviation, 16. So simplify, you'll get 0.03. And again, we use the z table. It's now positive. So let's go to the second page. 0.03 is here with an area 0.5120. So that is the area below z sub 1. For z sub 2, substitute the value of x sub 2, which is 119.5. Say mean and standard deviation. Simplifying, you'll get 1.22. Again, it's positive, so we stay on this page. 1.22 will be having this area 0.8888. Then last step, to solve for area between, we need to get the absolute value of their differences. And so we'll be having a result of 0.3768 or 37.68%. And that is now the area in between the two given scores. Now we already have examples of word problems wherein we are solving for area above, area below, and area between. But at this point, maybe you are still thinking, what values are we going to add or subtract? So we are going here to emphasize some shortcuts when rounding off the value of it. So in default, if there is no specific given of rounding off, we automatically assume that we are rounding off to the nearest whole number because we are adding or subtracting to a value or to the value of x. Why are we adding or subtracting? It's because by literally defining the keywords, we will be able to identify if these values will be including or not. Hence, we add or subtract. So let's have this keyword. What if in the problem you'll see between 50 and 76? Say for example, you are tasked to round off to the nearest whole number. So if it is between, they are not included. 50 and 76 will not be included. So that will mean plus and minus. So where are we going to add to the lower number? Where are we going to subtract to the higher number so that the values in between will be considered? So if it is rounding off to the whole number, the value that we're going to add or subtract is 0.5. So say for example, in the given word problem, we are tasked to solve for the nearest whole number, or there is no specified rounding off given, we automatically assume it's rounding off to the nearest whole number. So the new value of x sub 1 and x sub 2 will be 50.5 and 75.5. So it's just a matter of evaluating. What if, another case, you are not tasked to solve or to round off to the nearest whole number, but to round off to the nearest tens? This time, we are just going to add the place value of the original 0.5. So just like a while ago, we added and subtracted 0.05. To the lower number, we add. To the higher number, we subtract. What value? 0.05. Because if we round off to the nearest tens, we need another place value, which is hundreds, for us to be able to round off to the nearest tens. That's why we just simply added zeros to add a decimal place, or to add a place value. So if we are tasked to round off to the nearest tens, that will be 50.05 and 75.95. What if we are tasked to the nearest hundreds? We are again simply going to add a place value to the original default number we're adding or subtracting 0.5. So since we want to round off to the nearest hundreds, which is this decimal place, we need another number to the right so that we can round off to the nearest hundreds. Hence, we're adding 0 to add decimals and to add a place value. So that will be 0.005. So we add 0.005 to the lower number and subtract to the higher number. The values of x will now be 50.005 and 75.995. So your key takeaway here is what will be the value that you're going to add or subtract if you're tasked to round off to the nearest whole number, to the nearest tens, and to the nearest hundreds. So if it is whole number, you add or subtract 0.5. If it is to the nearest tens, add or subtract 0.05. If it is to the nearest hundreds, add or subtract 0.005. Your keyword here is area between. So again, where are you going to add or subtract? You add to the lower number, you subtract to the higher number. And that can be your clue. So again, this is the case where it's area between. Let's have another example. What if the keyword given is higher than 90? So when we say higher, that is synonymous to area above. So if we say higher than 90, we are not going to include 90. So in the number line, if you can see 90 here, we only want values higher than 90, thus not including 90. So for us not to include 90 in getting the area above, or for the values of the area above, we are going to add. So if it's higher, we add. So if we are tasked to round off to the nearest whole number, just add 0.5. Tens 0.05 and hundreds 0.005. So your takeaway here is the keyword higher than. So if it says higher than, we're going to add. How about lower than? This is the exact opposite. So if we have 90, it will not be again included, and we want the area lower than 90 or to the left of 90. Hence, we're going to subtract. So if you can identify the logic here, whenever we want to go beyond, we add. Or if we want, the area above, we add. But if we want the area below, we subtract. So if is, again, the nearest whole number to be rounded off, we are going to subtract 0.5 if nearest whole number, 0.05 if nearest tens, and 0.005 if nearest hundreds. And when we say lower than 90, we are talking about the area below x, or the score. Another keyword is at least 20. When we say at least, it's greater than or equal to 20. Now, if we try to illustrate it in the number line, and here is 20, when we say at least, we now want to include it. So 20 will be included. This is the starting point, and going to the right area above. But since we want to include 20, we need to subtract so that we can move to the left and have this border line or this mark before we go to the area above. So if we want to round it off to the nearest whole number, we are subtracting. Again, we are subtracting so that we can include 20 in the area above. If we are tasked to round off to the nearest tens, that's minus 0.05. And for the nearest hundreds, that's 0.005. So your takeaway here is, if we're talking about the keyword at least, you are going to subtract to x, and we are solving for the area above. So at least means area above, and 20 is included. That's why we are subtracting either 0.5, 0.05, or 0.005. How about at most? This is already the example a while ago. When we say at most, it's greater than or equal. So again, that means 64 is included. So in the number line, if 64 is here and we want to include it, and we want the area at most also means area below, because that is area to the left of 64. 64 is already the maximum. So if we want to include 64, this time we are going to add. So if we are rounding off to the nearest whole number, add 0.5, nearest tens and hundreds the same. And again, when we say area at most, or if we have a given keyword of at most, we are pertaining to the area below. If we have over 15, that is the same as higher. So if we have 15 here and we want values over 15, we do not want to include 15. That's why we are going to add. And that means area above. Let's now proceed to example number 3. The average life of a certain type of small motor is 12 years, with a standard deviation of 3 years. The manufacturer replaces free all motors that fail while under guarantee. If he is willing to replace 4% of the motors that fail, how long a guarantee should he offer? Assume that the lives of the motors follow a normal distribution. So that's already the answer. Our task here is to solve for x. What's given here is the average or the mean. This is mu. Obviously, the standard deviation is 3. Notice that the average is in terms of years. So we are talking here about time. So if the question is how long, we are pertaining to the value of x. What value of x will be illustrating this 4% of the motors that fail. So let's first analyze what we mean by 4% of motors that will fail. So 4% motors that fail also means area below. If we try to graph it using the normal curve, the mean is in the middle, which is 12. And we are talking here about the motors that will fail. So that should be on the left region. So fail is something negative, so it should be found here on the negative side of the curve. So we'll be considering this 4% area below. So this is what we are pertaining to here. Now we are solving for x given the area, mean, and standard deviation. So we need to identify the closest value to 0.0400. So 0.04. Notice that we should be on the negative values of z. So let's proceed to page 1. So 0.04. We need to locate the closest value, and that should be 0.0401. So the closest area to 0.0400 is 0.0401 with a z value of negative 1.75. Let's try to verify that. So this is 0.0401. The z is negative 1.75. So that's correct. Then after that, we simply plug in to the formula. So remember that our general formula for z is x minus mean all over standard deviation. We are solving for x given z, mu, and standard deviation. Z was identified a while ago as negative 1.75. X is missing. Mu is 12. Standard deviation is 3. Now what we can do next is to cross multiply. So that will be negative 1.75 times 3, which is negative 5.25 equals x minus 12. So to solve for x, we transpose 12 to the other side. That will be negative 5.25 plus 12. So the value of x is 6.75 years. So the answer in this problem is 6.75 years. So if you can see a given area, technically, you will be either solving for z or the score. Lastly, for example number 4, the IQs of 500 applicants to a certain college are approximately normally distributed with a mean of 110 and a standard deviation of 10. If the college requires an IQ of at least 95, how many of these students will be rejected on this basis regardless of their other qualifications? So we need first to know the given. We are talking here about a cutoff grade of at least 95. So if you get 95 and above, you will be a passer. And at least 95 based on our recall a while ago will be related to area above. So if the mean is here in the middle, which is 110. That's given. The ideal passing score is 95, which is below the mean. If we plot 95, it will be to the left of the mean, which is 110. So 95 must be somewhere here. And this is a score. So the passers will be from 95 and to its right, or everything greater than 95. We are asked to know how many of the students will be rejected on this basis regardless of their other qualifications. Now, the total number of applicants is 500, and we simply need to know the area of rejection and get the percentage with the given total of 500. So the percentage of rejected applicants is also pertaining to the area below 95, or this will be solved by using the area below 95. So the rejection region will be from this point and everything to the left. So this will be the area for rejected students. So for us to be able to solve that, obviously we need to know what will be that area. So we are going to round it here off to the nearest whole number because there's no specification. We are going to add or subtract to the score. So if you want to know the area, of course, we need to solve for z, and before we can solve for z, we need to know if 95 will be included. So this is 95. We want the scores less than 95. So what are the scores that will be considered as rejected? It should be lower than 95. So the rejection region can also be pertained to as scores lower than 95. So 95 should not be included. That's why we are going to subtract. Since we are rounding off to the nearest whole number, that will be 95 minus 0.50. Therefore, the value of x that we're going to use is 94.5. So we can now do the usual, solve for z. That will be 94.5, the new value that we are going to use, minus the mean 110 and standard deviation of 10. The z will now be exactly equal to negative 1.55. So again, we refer to the z table and find the area of negative 1.55 as z. So this is negative 1.5. Negative 1.55 will now have an area 0.0606. So the area below 95 or lower than 95 is 0.0606 or 6.06%. That is the shaded area. And we can use this probability or area to know exactly how many students will be rejected. We already have a total, which is 500. So for step 3, get the percentage from the total of 500 applicants. We already know how many percent will be rejected, and we already know what's the total. So it's just a matter of getting their product. So the percentage or the number of students that will be rejected is simply the product of 500 times the area, 0.0606. So therefore, 30.3 or 30 students will be rejected on this basis regardless of their other qualifications. So out of 500, only 30 will be rejected. So that means the number of students who will be accepted will just be the complement, which is 470. And that is all for this video. See you again on the next one.